Well, hi, it's great to see everybody. I'm Melissa Stewart. I'll be leading the first part of this training this morning, and I am an engineering manager at Efficiency Vermont and a subject matter expert in refrigerant management and refrigerant transitions in HVAC and refrigeration systems, especially in the commercial and industrial sector. That's kind of the side I come from. I'm also an engineer myself who specializes in decarbonization in industrial and commercial sectors. And Li Ling will be leading the second half of the webinar this morning. Li Ling, you want to introduce yourself?
Yeah, thank you, Melissa. Hi, everybody. Welcome. Thanks for joining us. This is a topic that I feel like is gaining some urgency as we close in on the end of the year, and I'm really glad that you all are motivated to learn more about it. Melissa, there's just a lot. There's a lot that we're going to cover. There's a lot that we're not going to cover. And so I want to ask you to put things in the chat that you particularly are hoping to hear today. And it's possible that it's not something that Melissa and I were planning to cover. And so we might be able to, address that knowing that you want to hear it. We can change up our comments to respond to what you want to hear from us. Also, there might be some more complicated kind of question you want to ask. If you punch the raise hand button, then Bryn can interrupt us and we can unmute you and you can ask your question live. And we're happy to do that. Everybody's muted to start with, but we're happy to have a back and forth. So please, engage, let us know what you want to hear. We put together things that we thought you'd want to hear, but if there's something that we know that is outside of our presentation and it's really important to you, we definitely want to know about that. So again, welcome, and we're going to get rolling because there's a lot of content here.
All right. So we've got a few broad topics to cover today. First, I will be talking some about what the refrigerant phase down is, and then what A2L and A3 refrigerants are and why they matter in this conversation, as well as some of the new technologies that are coming on the scene. And then Li Ling will take over to talk about how to get your business ready for the changes coming in the HVAC and refrigeration market in the next couple of years. We're going to focus a lot on heat pumps today, but we can talk about whatever technologies y'all are curious about. And here we go. So what is the refrigerant phase down? You may have heard that phrase, or maybe this is the first time you've ever seen it. And why is it a big deal right now, which is the case that we're making? And you may be asking, what does a picture of birds on a power line have to do with anything? Well, as I'm sure many of you in this space know super well, there's a huge and increasing demand for electrification of heating and cooling systems right now. And electrification has a crucial relationship with the refrigerant phase down. So that's what the power lines are for. As we shift away from fossil fuel-based methods of heating spaces, we are shifting toward equipment that uses the vapor compression cycle to move thermal energy around, like the coils on the back of a fridge or refrigerant loops or line sets. In this crowd, don't probably need to explain that every time, but just in case we've got some non-technical friends in the audience. Those loops that connect the indoor and outdoor units of heat pumps and other vapor compression cycle technologies. So as this push towards electrification is going on, it means there's an ongoing increase in refrigerant-bearing equipment. In the last few years, this year, in the coming years, that's happening, and it's going to continue to happen, driven by decarbonization efforts around the world. So part of climate action in the past decade by governments, including the US, involves reducing the negative climate impacts of the refrigerant chemical fluids that are used in those vapor compression loops that are absolutely everywhere in HVAC and refrigeration equipment. So laws have been passed to phase down the use and global warming impact of refrigerants on the planet. That's the refrigerant phase down. And in the HVAC and refrigeration sector, we need these phase down plans and rules in order to prevent our electrification work from accidentally offsetting its climate benefit through refrigerant emissions. This is because most of the refrigerants that are currently in use around the world are super potent greenhouse gases. And I will come back to the specifics about those chemicals and their characteristics later on. But for now, we want to focus on the refrigerant phase down regulations passed by our own government here in the US, because those regs are the engine driving the practical changes you're going to see on the ground in HVAC and refrigeration businesses in the coming months. And it's worth pausing to consider, just to think about that this phase down has been going on for a while, and it doesn't only affect HVAC. Folks in industries that produce foam blowing agents and aerosol propellants are involved, so we're not alone over here in our sector putting in residential or commercial HVAC. It's also important to note that refrigerant phase downs have been successful before. Residential refrigerators and car AC systems have already transitioned successfully, and our sector is following in their footsteps. So, and then also back in the late 80s, if you've heard of the Montreal Protocol, ozone depleting refrigerants were phased out, and that's been done successfully. So this is a path we've walked down before. We're just in a new phase as a sector. All right, so I mentioned regulations. What are the current federal regulations about refrigerants? Well, first we've got let me advance my slide, the Clean Air Act, under the authority of the Environmental Protection Agency. Section 608 of the Clean Air Act is where the HVAC technician certification is called a 608 cert comes from, which many of you have probably heard of or have yourselves. This has been around a long time, and it relates to the older ozone depleting kinds of refrigerants that are no longer being manufactured. The EPA also has a policy called SNAP that lays out which refrigerants can be substituted for outlawed types. And SNAP stands for Significant New Alternatives Policy. I just mentioned both of these top ones on the right because I know you may have heard of these or you may come across them, and they do relate to refrigerants in our sector, but they're not what we're talking about when we talk about the refrigerant phase down that's going on right now. 608 certification is important. It's not what we're talking about. The current phase down that we're all in now is based on the US AIM Act that was passed in 2020, towards the tail end of the prior administration, which gave the EPA authority to start phasing down the use of super potent greenhouse gas refrigerants called hydrofluorocarbons or HFCs. We'll talk more about HFCs today, but for now, as we're setting up this discussion around the phase down, you just need to know that they're really powerful greenhouse gases, which you're probably aware of. Okay, so the American Innovation and Manufacturing Act, or AIM Act. As I alluded to before, when Congress passed this act in 2020, they mandated that the EPA phase down the use of HFC refrigerants in the US. So that was like the directive, the job they were given. And they gave the EPA authority to make rules to achieve the tasks in three main areas, which they often talk about as being the three legs of a stool. And here they are. The first leg that they worked on first was the HFC production and consumption phase down of the chemicals themselves. The second one is called the Technology Transitions Program. And the third one is management of HFC use and reuse in the market. And on the next few slides, I'm going to go through each of these at a high level and start very high, I promise. We won't spend too much time here. Most of the requirements that come out of the AIM Act land on equipment manufacturers, but contractors and technicians will have to make some changes too. So it is helpful to understand what each of these things means sort of broadly without getting too far down into the details. Okay, when the AIM Act was passed in 2020, the first task of the EPA was to make rules to cut down the production and consumption of the chemicals themselves as a percentage of a baseline value that was calculated from data in 2012 and 2013. And this is that schedule. If you've ever been in one of our webinars about this, you're probably sick of this chart, but this is the schedule of the first leg of the stool of the AIM Act. Along the horizontal x-axis of this graph, it doesn't look like I can use my arrow, but you guys are smart. All right, along the bottom axis of this graph are dates by year, and the vertical y-axis shows percentages of that baseline consumption. As you move from left to right across the graph, you can see that it's structured around a series of step-down periods. Begins in 2020, which was 2 years after the act was passed, with a 10% reduction across 2 years between 2022 and 2024. It started out at 90, which meant it had to cut down to begin with 10%. And then in 2024, which you may notice is this year, there's the first really major step down of another 30% for a 40% total reduced from that baseline. And the EPA has a 5-year period to achieve that 40% total reduction versus the 2012-2013 baseline. And then in 2029, there's going to be another one with 5 more years to achieve it. And then there'll be more in 2034 and 2036. Yeah, there's smaller step downs. It's all going to add up to an 85% reduction by 2039. That's the goal of the overall rule. Great. So what do I mean that the EPA made rules to achieve those phase down steps? Like, what in the world does that mean? Well, for this first leg of the stool, they created a system of allowances or credits that the manufacturers of the refrigerants in HVAC and our equipment must adhere to. So this has to do with making the actual chemicals. They went through a long process of investigation and getting lots of feedback cycles from the manufacturers and getting all the objections and notes and addressing them. And then they assigned a budget of credits that dictates how many units of HFC chemical refrigerants they can produce or import into the country. Those credits are per company and per calendar year. And you can read all about how they set that up on the public-facing website if you're curious. I have a link there, but it's pretty easy to find in Google. But the main idea is that if that baseline volume of HFCs I talked about is a big pie, then the EPA is shrinking the size of the overall pie over time by those total percentages on the chart in the previous slide, just making the whole pie smaller. The phase down schedule is related to how big that overall pie can be by time period for consumption and production of the, I know I'm repeating myself a lot, but this stuff's confusing, was really confusing to me the first time I learned it. So the phase down schedule on the previous slide, which I'll go look at for a second here, this has to do with how much are they going to shrink the circle, the whole pie. Give me just a second to find my place in my notes, sorry. Okay, so the credits they assign each year per company are the slices of the pie, right? And they are hard numbers and they are enforced. So this is just an example of the biggest companies involved in the allocation and credit system on the consumption side or on the production side, to show you what I mean. For those of us in this virtual room today, the nitty-gritty details of who has what allocated credits isn't super important for us to understand because the manufacturers are the ones that have to deal with all of this before they can offer equipment or bottles of refrigeration for sale. But I want to try to make it super clear that the supply of new virgin HFC refrigerants is going to go down a lot over the next decade. And I want to give you a peek into this system also to help you understand why nobody can seem to tell you exactly how much of a specific refrigerant will be available at any specific point in time. It's because these allowances are based on the potency of refrigerant substances as greenhouse gases, which is a known property that's measured in units called global warming potential, or GWP. We'll come back to that later. But something to keep in mind here as you look at this pie and all the slices getting divvied up is that we will probably see the supply of the more potent greenhouse gas HFCs come down quicker because OEMs have freedom to work within their own pie slice to figure out how they want to use their credits. And it's based on that potency. It's not a mandate of you make X amount of R410A versus R134A versus R32 or whatever. It's up to them how they want to manage that. So we'll come back to this when we talk about GWP. But we can move on. But leg one of the stool, this is what's going on in that first rulemaking, which is law of the land. There are more charts than this one and more complexity to this. And if you're curious to dig in on it, it's all on EPA's website, or ping or email me after the webinar. I'm glad to point you in the right direction if you like to dig in on data. Okay, the second leg of the AMAC stool is the technology transition rules, which gives deadlines for when changes will have to be made in what types of refrigerant specifically can be contained in specific types of HVAC and R equipment. So there's lots of categories of equipment and different deadlines and ceiling values. But one we particularly want to highlight because it's coming up really soon and it's going to affect you and a bunch of our rate-paying customers is residential and light commercial heat pumps and air conditioners. According to the most recently finalized technology transition rule, that was passed into law. All new chillers, air conditioners, and residential heat pumps will be required to use refrigerants that have a GWP value of 700 or less by January 1st, 2025. There are many other categories of equipment, and you can explore them all in detail on the website I've got posted here. But just know that 700 is the highest ceiling in the next round of phase downs. Sorry, that's hard to say. And 2028 is the latest of the various deadlines. So by 2028, in every equipment category, we've at least going to be at 700 or lower. And some of them, the ceilings are even lower than that, and the deadlines are sooner. So just to restate it one more time, the second part of the AIM Act is global warming potential ceilings with deadlines in new equipment. Okay, so we're still on that second leg of the stool, the tech transition rule. It became law in October of last year, and it distinguishes between the categories of products and systems in this way. A product is functional upon leaving a factory, like a window air conditioning unit or a home refrigerator. The manufacture and import of this equipment is banned above that ceiling by the given deadlines with a 3-year sell-through period if it's previously purchased. And a system is assembled and charged in the field, like a rack or a split configuration system. And it has a 1-year sell-through for distributors. So if they have the stuff warehouse where they have a little bit of time to sell through, but repairs are allowed for systems kind of indefinitely. They have to meet a few specific requirements. And we can get into this in more detail later, but if anybody's interested. But one thing to note is that R410A or whatever refrigerant someone's concerned about in equipment right now is still going to be available. Replacement components will be available over the lifetime of the system. But at some point, better performance of new equipment versus repair will make new systems the obvious choice, but prices may increase as the supply pressure of all of these forces working together drives the supply of phased out refrigerants down. And folks who try to kind of, yeah, go ahead.
Hi, I'm sorry. I thought you were about to transition to the next slide. I'll let you finish with this slide, but I just want to address something that came up in the chat and is related to the slide. So when you're done talking, I'll add it in.
That'd be great. Yeah, I'm not looking at the chat at all. And another thing to sort of note as we're talking about this product versus system kind of thing, there are always going to be folks who sort of try to exploit endless loopholes for repairs, but they are in danger of avoiding the warranties on their systems eventually. So yeah, Li-Ling, what's up?
So Andy asked in the chat, let's see, quote Andy correctly here. No, I guess I can't do that. He says, when will R410A equipment no longer be available for installation? So what Melissa said on the previous slide was 2025. And what I said as an answer in the chat is 2026. And so there might be like a confusion about that. And Melissa referred to that on the next slide, the one that she was just talking about. She said that for systems, there's a 1-year sell-through. So the 2025 date applies to manufacturing. OEMs will no longer be able to manufacture equipment that uses R410A as of December 31st of this year. So starting January 1st of 2025, all new manufactured equipment will not be using R410A. It has to use a refrigerant that's below the 700. So what happens to equipment that was manufactured in 2024 and hasn't sold yet, say in January or May of 2025? That's the sell-through period. So any equipment that was manufactured in 2024 can be sold and installed through 2025. And that's why I said January 1st, 2026, you can't install new R410A equipment starting January 1st, 2026. But the truth is you may not even be able to buy it in, say, June or July of 2025. You may not be able to buy it in January of 2025. There are some manufacturers that even now you can't get R410A equipment. So the answer to your question, Andy, is 2026. But that doesn't mean that you will still be installing R410A equipment in October of next year. You may have already transitioned at that point.
Yeah. Okay. All right. The final third leg of the AIM Act stool is an emissions reduction and reclamation rule that has been officially proposed, and this is, or excuse me, emissions reduction and reclamation rule that has been officially proposed. And proposed, and in this world of things I've learned in the last few years on digging in on this, is what kicks off the legal process for the rule to become a law. So there's like a timeline that it goes on once it's been officially proposed, and then it becomes the law. So this is the first step that the EPA has taken so far toward meeting their mandate in that third part of the AIM Act to deal with HFC use and reuse, so sort of existing HFCs and systems. And this proposed rule has some new requirements for leak repair and automatic leak detection and use of reclaimed HFCs in new equipment. And the requirements will kick in on different timelines, ranging from 30 days to a year after the final rule is published. When they roll one of these out, there's like a big detailed document that gets published, like a PDF that anybody can access, and then they usually have like a summary fact sheet that summarizes everything. And that will come out, and they'll have a table where they explain what kicks in when. The use of reclaimed HFCs represents a big expansion of the market for reclaimed refrigerants, because this is going to hit manufacturers where if they want to make new equipment with certain with HFCs in it, they are going to have to use reclaimed. So they will need a source for reclaimed HFCs. So keep all this in mind. Li-Ling's going to talk more later about this new market for reclaimed HFCs and how that is a potential source of revenue for folks in your line of work. And that this rule is expected to become a quote final rule, meaning binding and legal, in October of this year at the latest. We may have even seen it a little sooner than that. We will see. Okay, so now you're experts on the US refrigerant phase down, which is mostly talking about those AIM Act specific regulations. To continue setting the stage for some of the practical guidance that Li-Ling is going to give you later on, I need to switch topics a little bit and talk about some categories of refrigerants called A2Ls and A3s. What are they, and what does it have to do with all of this that we're talking about? Why should you care? Let's find out or review in many of your cases. Before I get into those subcategories, I'd better back all the way up and just quickly say what refrigerants are. The simplest definition is that they are the so-called working fluids in refrigeration cycles, which just means that they carry energy. They're the physical fluids that allow any technology with a refrigeration cycle to move heat, or if you want to say it in a fancier way, move thermal energy from one place to another. And this is how these technologies can either cool something down by removing thermal energy from a space and putting it somewhere else, or warm something up by putting it into a space carried from somewhere else. Refrigerants are also chemicals, and they are categorized by a number of different properties. The first broad property of refrigerant types is whether the substance is synthetically created, like in a lab that wouldn't exist otherwise, or a naturally occurring chemical. All refrigerants are produced or processed and packaged in the chemical industry in some way, but synthetics have patents owned by particular companies, while naturals don't. So moving from left to right across the top of this slide are the categories of synthetic refrigerant chemicals and their abbreviations, and this goes from oldest technology to newest: CFCs, HCFCs, HFCs, and most recently HFOs, or hydrofluoroolefins. Say that 3 times fast. Let's see, CFCs were the very first synthetic refrigerants, one of the most famous of which is known as Freon. And as the chemical industry continued to innovate and improve performance of their products and address safety and environmental hazard concerns, HCFCs came on the scene, followed by HFCs, and most recently HFOs, and we'll talk about some of the reasons why later on. But the other broad category, as I mentioned, is natural substances, and some of these include hydrocarbons, which just means that they're made up of hydrogen and carbon atoms, like propane, butane, isobutane, those kinds of things. And then there's carbon dioxide, or CO2, and ammonia, which is a totally different sort of chemical made up of nitrogen and hydrogen. Another important chemical property of refrigerant fluids is their impact on the environment. Synthetic HFC types of refrigerants are super potent greenhouse gases, as I've said a few times before. Their impact is measured and described in this number called the global warming potential, GWP, which is the relative impact of a substance as a greenhouse gas with carbon dioxide as the reference. So GWP is a multiple of the greenhouse gas impact of CO2, of carbon dioxide. And I just want to illustrate the GWP impact of common HFC refrigerants with this one specific example. Here's the refrigerant that's almost always used right now in residential air-to-air heat pumps, like the ductless mini split on the wall at my house behind me right now in my blurred out background. It's an HFC blend called R410A. It has a GWP value of about 2,000. So if 1 pound of the charge in the unit on my wall leaks into the atmosphere or is released during installation or disposal, it's equivalent to a ton of carbon dioxide. There's a couple of alternatives that are just beginning to be adopted in the US. We'll come back to those later on. But for now, just want to drive home the point that the refrigerants currently in our HVAC technologies have a tremendous impact on the climate if they end up in the atmosphere. Another way that synthetic refrigerants impact the environment is through their breakdown into forever chemicals in the atmosphere. Most types, including even some of the quote lower GWP HFO kind of chemicals, do this. And there's a couple of exceptions, but this is broadly true, where these synthetic refrigerants break down into components that never go away in the environment and end up found kind of everywhere and inside our bodies and animals' bodies. And it's a problem that a lot of folks are trying to tackle right now. So refrigerants make vapor compression cycles work by carrying energy, right? They have an impact on the environment, but they're also handled by contractors and technicians, as I'm sure you all know better than me. So another important aspect of refrigerants is how they affect the people who work with them. ASHRAE, which stands for the American Society of Heating, Refrigerating, and Air Conditioning Engineers, categorizes refrigerant chemicals separately from all those other properties that I talked about by their safety category when it comes to the people handling them. We'll come back to this in a few minutes, but we have to talk about this for a second just because it's so important when we talk about shifting the industry from these high GWP refrigerants into other types. There are 2 parts to the safety categorization. Toxicity is designated using A or B. A is non-toxic and B is toxic or poisonous. That's shown along the bottom. And flammability is given a ranking from 1 to 3, where 1 is completely non-flammable, 3 is highly flammable, and there's a category called 2L to give a label to refrigerants that are only very slightly flammable. So there we go. We've got A or B, and we've got 1 to 3 toxic flammability measurements. So to try to understand what all this general information means with some real numbers, let's look at the specific example again of the ductless mini split. The current industry standard refrigerant is R410A, and as we already talked about, it's got a GWP of 2,000. Due to the AMAC phase down schedule I showed earlier, the EPA has finalized a rule that gives ceilings for the maximum allowed GWP value. So for ductless mini split residential heat pumps like the one in this picture, that ceiling is going to be 700, kicking in on January 1st, 2025 with the sell-through period that we discussed a little bit with the comment in the chat. And I chose this example because it's the one most of us are probably familiar with. Manufacturers are starting to offer alternatives because they've known this change was coming for a long time, for many years. There are a couple of synthetic options that will have GWP values under 700 to meet that phase down period requirement that are already starting to be offered in new products, R32 and R454B. And while we don't have this technology widely available in the US yet, in other countries, they're using R290 a lot. Not just for the sort of bare minimum compliance way of thinking about this, but also for like future proofing for the whole life cycle of the equipment, right? A lot of times people are getting heat pumps because they want to help address climate change, and we don't want those folks to accidentally sort of offset the good they're doing by electrification by installing leaky systems with high GWP values. I am going to skip the rest of what I had to say on this slide in the interest of time. Okay. So just to hammer it home one more time, a lot of common HFC refrigerants have GWPs that are up above 700, and new equipment's going to have to use other kinds. So the A2L and A3 slightly flammable and flammable category comes into play here because as we shift for this next coming 700 GWP ceiling, we're going to be moving from refrigerants that were non-flammable, this A1 category, into refrigerants that are A2Ls and A3s. So that's a shift for installation requirements and equipment manufacturer requirements. So what about codes and standards? We've talked a lot about the phase down major regulation. That's under the authority of the EPA, but what about codes and standards? There are product codes, installation standards, building codes, and other kinds of codes and standards at various levels from like local, town, all the way up to federal, and they're all meant to work together. It gets pretty complicated to get into specific codes and standards and who sets or updates them. So I'm not going to attempt to do that today, other than to say that all the various agencies involved are currently in the process of updating to accommodate A2Ls and A3s. From a contractor perspective, this is going to affect product manufacturers much more than you. Everybody deals with codes now, and these are just the newest updates. Code interpretations by the manufacturers, distributors, and suppliers leads to what's for sale, to what's available to be installed. You have that sort of last piece if you're in the HVAC installation business. You want to make sure that your technicians have the information they need to install compliance products safely, and your manufacturer reps will help you figure out how to install those systems. At the moment, for example, Massachusetts hasn't caught up on updating state level codes to allow A2Ls, and neither has Canada, but it's coming in both of those places. But here in Vermont and over in our neighbor state of New York, the codes have been updated, and these slightly flammable refrigerants and some of the flammables are allowed. Yeah, and sorry to sort of abruptly transition. I thought I had a better transition than that in my slide. Li-Ling, are you ready to begin your section of we're going to shift into more practical stuff. Yeah.
Okay. Thank you, Melissa. So before I do that, I just want to read some questions that were in the chat because when people listen to the recording later, they won't have access to the chat. So sure. Going back to some questions that have already been asked and answered, there was a question about whether Efficiency Vermont will continue to pay incentives on basically R410A equipment or refrigerants that have been phased out. And the answer is yes, we'll pay an incentive on any qualifying equipment that is legal to sell, buy, and install. So that means no R410A equipment after January 1st, 2026, but it's not legal to install that as a new system after January 1st, 2026 anyway. Let's see, I answered the second question that came through. I already interrupted you to do that one. And then, let's see, going forward, I feel like maybe I missed one here. Let's see. Oh, is there a push away from brazing? Is brazing discouraged as we're transitioning to higher flammability refrigerants? The answer is no, but you really need to be adhering to best practices around refrigerant recovery and evacuating the refrigerant loop. And I'm going to get into that a little bit more in the next part of the presentation. And then, so there's a question about codes. Vermont adopted the new codes, the new building codes that allow A2L refrigerants some time ago, a few years ago.
Yeah,
and so it's actually been legal to install A2Ls in Vermont for some time. Okay, I think those are all the questions. I'm not going to be responding to the chat, but I think that Melissa and Bryn will be, and they will interrupt me as I interrupted Melissa if there's something that I should address in the moment. And if you raise your hand, then we can address your question in the moment also. So there's going to be a little bit of an awkward transition here while I move over my side of things.
Technology.
Okay, so let's see. In preparing for this, putting this presentation together, I should just make clear, in case it wasn't clear before, neither Melissa nor I are HVAC technicians. And I'm going to address a lot of things that are relevant to HVAC technicians, but I assembled all of this information by talking to OEMs and refrigerant reclaimers, tool manufacturers, refrigerant manufacturers, and policy people. So in listening to all that and trying to assemble it in a way that I thought would be helpful for you all, I feel like a lot of what I'm going to convey really falls into the heading of best practices. If you've been adhering to best practices all along, half of what I say is not going to be new to you at all. And if you haven't been completely adhering to best practices, not much of what I say will be new to you, but I really think that you need to start being more serious about best practices. And there'll be a point in this presentation where I'll show you some recommendations, but my message for you is maybe they're not requirements, they're only recommendations, but they're really important and it really should be what we're all doing. Okay, so the information that I assembled, I'm thinking is going into these categories. One, everything's going to be fine, right? We're moving to flammable refrigerants, yes, but everything's going to be okay. The second major category is the importance of refrigerant recovery. Then some operational characteristics of the new refrigerants. I think that's going to be really what most of you are going to appreciate hearing today. Working with flammable refrigerants, training for your technicians, and then business practices. So there are some things that are going to affect actually how you conduct your business. All right, so let's go to the next slide, Melissa. So a lot of changes coming at us pretty fast. I mean, one thing that I think that I have heard from people is like grumbling about like, why are they, shoving this down our throat? And I just want you to know, like, this is happening. There is no dialing this back. There has already been many rounds of comments and refining the rules, but now the rules are in place and we're not going back. It's definitely going to happen. We're going to stop using R410A. And so Melissa and I have been talking about the flammability of these substances. The substances that you work with every day, now you're going to be working with, flammable substances, but everything's going to be okay. And this is, I'm just going to go through these really quickly here, the things that are on the slide, but it's all in helping you remember that there's a lot of work is going into making this transition go smoothly. So next slide. Okay, safety. I will refer to A2L refrigerants as being flammable, but actually they're really hard to ignite. And many of you on the call have probably seen the YouTube videos about trying to ignite A2Ls, and if you haven't seen them, they're sort of entertaining. But the point of all of this, and really everything that you will see about A2Ls, is they are really hard to ignite. However, because they are flammable, technically flammable, they're the subject of many of the safety protocols that are required of all flammable gases. And as a result, they're giving all of us a great training ground for working with the more flammable refrigerants that are already in use now, right? Some of you may already be working on R290 systems. And those more flammable, those A3s, they're coming to HVAC. So, I don't know that Melissa mentioned this, but the technology transition that we're in the middle of right now, it's not the last one. Eventually, we'll all be using these ultra-low GWP refrigerants, right? We're in the middle now. These are lower GWP refrigerants, the R32 and R454B, but we can't stay there. We ultimately have to get to the GWPs that are like 0 or 1 or 2, right? Not 700. So all of us are going to be working with truly flammable refrigerants at some point. And here, working with A2L refrigerants is a good time to get all your technicians trained up about best practices working with flammable refrigerants. And the codes and standards have been written, even if they haven't been universally adopted. So Melissa alluded to Massachusetts is sort of slow on the ground, adopting the national standards. The purpose of the codes is to keep all of us safe, and that includes technicians and the occupants in the building. And there's really not much danger in the new refrigerants, given all the safety features that the OEMs are putting into the equipment. So Melissa said, like, most of the requirements here really fall on the manufacturers of the equipment. But safety is why adhering to best practices is so important. And we're going to get, that's sort of at the end, I come back to that. Okay, next slide. Service. Okay, so service gas and replacement parts for legacy refrigerants, so all the R410A equipment that's out there now, and I just want you to know, like, Efficiency Vermont is planning to see 13,000 heat pump installations this year, and pretty much 100% of those are going to be R410A equipment. And so we're already, like, we're basically rushing right up until the deadline with R410A equipment. And if you're wondering, like, well, what's going to happen to all that equipment after the technology transition happens? Legacy refrigerants and replacement parts will continue to be available. And there's no point in this phase down where these legacy equipments will be banned. This is different from the ozone depleting refrigerants. They were actually phased out. R22 can no longer be manufactured or imported to the US, but that's not going to happen with R410A. So the OEMs, I've talked to a bunch of them and attended many, many webinars on this, and they're all very eager to assure us that they will continue to manufacture the replacement parts even after the technology transition has happened. And it is legal to do repairs and to replace parts. Okay, next slide. So OEMs, some applications are going to require site-built mitigation systems, because flammable refrigerant, and if there's a leak, there needs to be safety systems in place. And the need for a mitigation system depends on a lot of different things, including the charge size, the volume and compartmentalization of the space that's being served. So is it like, a showroom, or is it like a bedroom? Whether there's a circulation fan that's part of the system, and lots of other considerations. However, the OEMs are responsible for all that, and they're going to help you figure out how to apply the code requirements to your specific application. And they're responsible for building the leak detection systems and making sure that it's compatible with, the different models of stuff that they make. So you're not alone in putting together a system that's going to keep the occupants safe. That doesn't fall to the designer or the technician. Okay, next slide. Okay, so this is, I think Melissa already mentioned this, but we've been through this, right? We went through this and tried to save the ozone from being completely dissolved, and the ozone hole is closing. And so those regulations worked, and the whole process of like making laws and then regulations and then changing what the industry is doing, we've been through this before. So, it's not, this isn't the first time. It can be successful. We've all been through it. And I also want to say that the requirements of the current, the phasing out the HFCs, that's already been in place for a while. Like vehicle air conditioning already transitioned. If you go and buy a new refrigerator now, even though the technology transition isn't enforced yet, they've all transitioned to, many of them, A3 refrigerants at this point. So we're in the middle of this. It's not like it's an unknown thing. It's a known thing, and it's successful, and we're already doing it. Okay, next slide. All right, I suspect that if you were listening to Melissa, that you might be asking yourself, well, okay, so now there's going to be less R410A available. What's going to happen to the cost of that? And it is true that scarcity is part of the transition. It's all like sort of baked into this, and there is an expectation that the cost of legacy refrigerants will go up. And we don't really know exactly what the future holds, but we can just guess that all high GWP refrigerants are going to be more expensive. And for you and your customers, a consideration of the cost of refrigerants is going to have to be a part of the decisions that you make as a business, like how you advise your customers about repair and replace. So production and importation of R22. So what we're showing on the slide here is just the cost of R22 over time. And this is different from what we're doing now, because what we're doing now is a phase down, and R22 is actually phased out, and it was banned in 2020. They took too long. This is one of the things I think was learned from the phase out, is that they took too long to do it. And so that's part of why this is moving a little faster than the phase down. So you can see from 2014, when the phase out began, so that was the beginning of a restricted supply of R22, to 2017, the prices of R22 basically doubled. And then in in just the year 2020, when production ceased entirely, so that was, there was no more new version R22 at that point, the cost of R22 shot up. So it's, maybe a little predictable, but I wanted to show you this chart because this is what we're expecting to happen with R410A. And, you might sort of wonder, why didn't the cost of R22 just keep going up and up and up after 2014? And I think this is going to also happen with R410A equipment, is that eventually, to 10 to 20 years from now, the number of R410A systems out there is actually going to start to decline, right? Because they'll get to the end of their life. And that's going to be the thing that maybe levels us out a little bit, and it's not just going to go up forever. Okay. Yeah, I have here in my notes one more data point. 5 years ago, R404A, which is a high GWP refrigerant that's used in refrigeration, it was $300 per 100 pounds. And today, 5 years later, it's $2,000 per 100 pounds. So the cost of legacy refrigerants is really going to be something that we all are going to have to consider. It's going to be available, but it's going to be more expensive. Okay, next slide. So really, after sort of taking on board all of what's going to happen here, including that cost piece that I just told you about, and what we're going to need for service gas in the future, I've come to see refrigerant recovery as really the most important change that the industry needs to make. And it's not just because of refrigerant supply. It's also because the whole purpose of this phase down is to reduce the climate impact of our refrigerant systems. And if we just let all the refrigerant that's out there now just leak away very slowly, then we will have done nothing really to mitigate the impact of these high GWP refrigerants. So we not only need to recover refrigerant, but we need to reclaim it. This chart here, it comes from the EPA, and it shows how much refrigerant has been recovered and sent to reclaimers in the last 20 years. If you just look over on the right side where they start adding in those green bars, that's where the EPA started tracking HFCs. So remember, like R410A is an HFC. They started tracking HFCs separately from the other refrigerants. So a lot of those like refrigerants in the blue bars, those are the ozone depleting chemicals that are regulated in a different way. So in the time that the HFCs were tracked differently from everything else, the amount of refrigerant that is recovered has basically stayed flat. I mean, sure, there's like a little bump there at the end, but the point is it's not going up, and it is grossly insufficient for what we need. And I'll come back to this. Melissa already mentioned it, and I'll come back to it. But there are going to be requirements on refrigerant management that will require that new systems that service gas cannot be virgin, basically. So in order to meet the expected need for service gas, the industry needs to increase the amount of reclaimed refrigerant by 5 to 8 times. And that has to happen by 2028. And I'll explain that later on. And that analysis is done by Hudson Technologies, which is a reclaimer. So I'm going to say this a few times, but the refrigerant you recover today is going to make it possible for you to buy service gas tomorrow. Like the system cannot work if people are not recovering and reclaiming refrigerant. Okay, next slide. So reclaimed refrigerant is going to become a larger and larger part of our refrigerant mix, and that's obviously going to apply to legacy systems. And it might not, these aren't new refrigerants. Like a reclaimed refrigerant is refrigerants that you've already been working with, but it might be new to you to use reclaimed refrigerant instead of virgin refrigerant. Maybe you're just in the habit of buying virgin refrigerant, and in fact, the supply of reclaimed refrigerant has been pretty low based on that chart that I showed you. People are not recovering and reclaiming very much. So if you remember back to the phase down chart that Melissa showed, you'll understand that the refrigerant that's needed to service the existing equipment that's out there, it's going to have to come from somewhere besides new manufacturing. There just isn't going to be enough virgin refrigerant manufactured, and the manufacturers of refrigerants, they might decide it's not profitable for me to manufacture R410A. I'm going to use my allocation to manufacture something different. So we don't know, but it may be that there is no virgin R410A in 5 years. So right now, just as an example, all the R22 that's used for servicing, the 15 to 20 million R22 systems that are still in service in the US, all of that refrigerant is reclaimed. So, you know, eventually the same is going to be true for R410A and the other higher GWP refrigerants. So reclaimed refrigerant is as pure as virgin. In fact, it could be more pure because there are no purity standards for virgin refrigerants because they're virgin refrigerants. So only reclaimed refrigerants are tested. So it's possible that they're actually more pure. And the performance is exactly the same, right? Because they're as pure. And that allocation system that Melissa showed in the pie chart, it doesn't cover reclaimed refrigerant. There's no limit on how much refrigerant can be used for service as long as it's reclaimed. So again, I already said this, but if we're going to have any supply of legacy refrigerants at all, you need to be recovering refrigerants. There's no other source of reclaimed refrigerant except being recovered out of systems. We had a training on best practices for recovery on May 9th, and I believe that the recording is available at the link that Bryn either already posted into the chat or will post into the chat. So Efficiency Vermont's trying to help people, you know, do better with refrigerant recovery. We had a training about that. Okay, next slide. So this is a little bit about the regulations about recovering refrigerant. So I just want to set this up by saying, you're all going to be servicing equipment with legacy refrigerants for a really long time, right? Just because we're transitioning to newer refrigerant, you know, starting now, really coming on strong January 1st, 2024, it doesn't mean you're going to stop working on legacy equipment that has the older GWP, you know, high GWP refrigerants in it. So you need to have service gas for that work. And it's one of the many reasons that I am going to strongly encourage everybody on the call and really everybody I talk to adhere to best practices all the time. So here's a reminder of what you can do with recovered refrigerants. You can put it back in the same equipment that it came from, or other equipment that's owned by the same person or company. Right, so I just want to repeat some little piece of that, which is the refrigerant belongs to the owner of the equipment. They own that refrigerant. And if they say, I want to put it in the other air conditioner, or, you know, this, I want you to reuse it, then they're allowed to say that. But you cannot use it in a different customer's equipment. You can't take it from one site and drive it over to a site that's owned by somebody else and put it in their equipment. And in fact, unless you know the history of the service on that equipment that you might have recovered the refrigerant from, I really think you should think twice about direct reuse. Like, do you know how well evacuated the system was before it was charged with refrigerant? If it, you know, if there's a high, if it's unknown whether it's contaminated, you really may not want to reuse that refrigerant. It's just not worth reusing because it'll, you know, hasten the demise of the equipment. And you, when you recover refrigerant, you really have to work to make sure that the refrigerant doesn't become contaminated in the recovery process, even if you won't be reusing it. And I'll come back to that in a moment. So the best practices around not letting the refrigerant get contaminated are evacuate the tank and purge the refrigerant hoses so that you're not mixing air into the refrigerant as you're recovering it. Use filter dryers before the refrigerant hits the recovery machine. That'll protect the recovery machine. And another filter dryer when you're putting the refrigerant back into the system if you're going to reuse the refrigerant right there. So you can actually clean up the refrigerant a little bit in the process of recovering, and if you're going to reuse it. So refrigerant that's been processed in the field like this, you put it through filter dryers and you put it back in the equipment, it's just called recycled refrigerant. And if you're not going to recycle, it's still a good idea to prevent contamination because that helps with the reclamation. If you can send cleaner refrigerant to the reclaimer, it helps them be able to reclaim more and better and at a better price. And replacement refrigerant is going to become more expensive, and the less recovered refrigerant there is, the more steeply prices will rise. So if you're worried about the increasing price of R410A, recover more refrigerant. So it's going to really help your customers and really like the climate, but also the whole industry and the marketplace for refrigerants if you get really good at repairing leaks. So it's going to protect your customers from scarcity and price escalation. If you have systems that you service where you're like every year you go in and you like top it off in a few ounces and you've never been able to find the leak, that's really not serving your customer well because eventually that few ounces of refrigerant are going to become really expensive. So find leaks, repair them, get good at that. It keeps potent greenhouse gases out of the atmosphere. It also helps your technicians sharpen their skills because when we're all using A3 refrigerants that really not only are highly flammable but explosive, we need to have leak-free systems. And keeping refrigerants in the pipe is best for the performance of the equipment. All right, next slide. So refrigerant that doesn't get reused right there on the rooftop or in the backyard, it goes to reclaimer for processing. And right now, if you are not getting paid for the refrigerant that you recover and send to a reclaimer, you're just not doing it right. Because right now you can get paid for pretty much anything that you recover, even if you don't know what it is. Like if you have a cylinder of something that you took off of one of your customers' properties that are like, I don't know what that is, you can take that refrigerant and just get rid of it, I don't know. You can send that in and get it tested, and if it is pure enough, you will get paid for that. So I know that there's been a long history of having to pay to return your refrigerants, but that is not the case now. The marketplace for refrigerants has changed. So get paid for that. It's worth money, and it could be worth so much money that could actually help your customers have enough capital to upgrade their HVAC system. So let's see. So here's what you need to have on hand to do quality recovery. So a recovery machine, and because pretty soon you're going to be using refrigerants in a different safety class, A2L refrigerants rather than just A1 refrigerants, you now need a recovery machine that's compatible with all the refrigerants that you use and you will be using. So probably that means that you're going to have to get a new recovery machine. And I encourage you to get like the new ones that have like onboard diagnostics, and they have like Bluetooth connectivity with the scale, and there's the new recovery machines are really awesome. And we had also a training on recovery that's recorded and also available on our website. So you need a refrigerant scale. And again, you can get scales that are communicating, and that's really nice because they can like be uploading information to the cloud, so it's like good for record keeping and reporting. You need a set of high-speed recovery hoses. Don't use refrigerant hoses or evacuation hoses for recovery. If you feel like you don't like doing recovery because it takes too long, you're probably not using the right hoses. And get a very short hose to connect the recovery machine to the cylinder, because that hose always has stranded refrigerant in it, and you don't want a long hose there because you're always going to leak that refrigerant out. So a short hose will minimize the amount of stranded refrigerant that's between the machine and that cylinder. So you also need a way to calculate the allowable fill weight on the cylinder based on the refrigerant type. So if you've only been using one refrigerant type, now remember you're going to be using more than one refrigerant type, so you need to get yourself an app that's already going to calculate that for you. And then you need a bunch of filter dryers, because if you can you don't want to foul your recovery machine, but also you want to keep the purity of the refrigerant as high as possible, because that increases how much you'll get paid for it. And you need enough tanks available, enough cylinders available in the warehouse that you're never tempted to mix refrigerants. And then, of course, you need to label the tanks. Okay, next slide. So, you know what? I'm going to skip over that because oh, go ahead.
Let's skip the next one. We did have a question in the chat of someone was thinking maybe for the first time about having flammable and slightly flammable refrigerants in the trucks and moving it around from place to place. I was trying to remember if we talk about that towards the end. I was curious about
yes,
what changed.
I do address that.
So. Okay.
Yeah.
All right, so skip this one and go to the next one.
Yeah. Okay, so when Melissa and I first did this presentation, we were addressing more than just HVAC people. So there's some stuff on here about refrigeration, which I'm just not going to address at all. But the part that's sort of on the left there, that is HVAC. And so, these are our new refrigerants, our R32 and R454B are the refrigerants that we'll be seeing in residential air conditioning and heat pumps. And I just thought that you all, as technicians, would be interested in some of these characteristics of the refrigerants. So I think, Melissa, if you advance, you'll get one arrow. Is that right? You have one red arrow now?
Yes.
Yeah, okay. So just looking at the capacity, R32, this is all relative to R410A. So R32 has slightly higher capacity and R454B has slightly lower capacity. But I don't consider these to be big differences. Click forward one more time, Melissa. The COP, so that's the efficiency, is a little bit higher for R32 and R454B. So glide, many technicians who have only worked with R410A, they probably don't even really think about glide. There is actually a little bit of glide with R410A because it's a blended refrigerant. R32 is a single component refrigerant, so there's no glide at all. And R454B is a blend, and it has more glide than R410A. So now technicians who have only ever worked with R410A, they're going to need to, learn the bubble point or, I'm sorry, terms that I'm not very familiar with. I did not mean to include that tone of dismissiveness in my voice, but I sort of slide into that because this is where I'm really at the edge of my knowledge because I'm not a technician. But in any case, glide is now going to be something that is going to be more relevant for technicians. And you need to learn how to deal with, that range. So just for people on the call who don't know, glide indicates that the refrigerant is going to change phase over a range of temperatures rather than at a certain point. And you can see why in R410A it seems like there's no glide because the range of temperatures is so small, but it's going to be quite a bit bigger with R454B. The temperature, the discharge temperature, this is in Celsius, unfortunately. I don't know if that's what you use all the time, but it does range a little bit, particularly between R32 and R454B. If you're installing equipment that has different lower GWP refrigerants, you're going to notice a difference there. And then the discharge pressures are pretty similar. They're close. And I'm just going to skip the part. I don't know if you've been advancing with me, Melissa, but there's just a bunch of arrows that move down, and we're gonna skip to the next slide to go to the next slide that's yellow and blue. So I just found this chart yesterday, so I don't really have much to say about this, but I thought you all would like to see this, the pressure temperature comparison between these different refrigerants. And because I don't have anything to say about it, I'm just going to stop talking for a moment. Okay, so let's go to the next slide. So I really encourage you to talk to your supply houses now. You maybe will keep installing R410A equipment to the end of the year. Maybe you'll even be installing some R410A equipment through some part of next year, but you need to know what's coming. So talk to your supply houses about what they have available now and what refrigerant the equipment that you install is going to be using in the future. And hopefully your supply houses are also going to be providing trainings on installing the new equipment. So I was able to talk to Daikin, Fujitsu, and Mitsubishi. I contacted these other folks and even some that are not on the screen here, and not everybody got back to me. But I can tell you that Daikin has made a big play to move very rapidly to the lower GWP refrigerants, and they were able to do that because the codes, were written in the U.S. to allow for that, and they've been in place for some time. And then the new equipment was only available in states that had adopted the new codes. And as I said, Vermont did that some time ago. I might even have, I don't have the date on here. But anyway, Daikin is the one manufacturer I know that has stopped manufacturing R410A equipment already. So it's, that even now, it's hard to get a hold of Daikin R410A equipment. Some of it, they took the last orders from all the supply houses like in June. And after they satisfy all those orders for R410A equipment, they're done. And they're switching to R32. They do require that any contractor buying the R32 equipment, they need to be trained. And so Daikin reps, but also the supply houses are offering that training. Fujitsu is going to be using R32 and Samsung is going to be using R32, but one of the Samsung products, the Hilux, is going to be using R454B. And then the ones across the bottom are using R454B as their new refrigerant. Bosch has a 5-minute online course, which truthfully, I don't think there's going to be a lot of safety information conveyed in a 5-minute online course. So there's one manufacturer that is not feeling like they are going to take it on to train technicians. Hire, I guess I did talk to the Hire folks, and they said that they are not going to have their new equipment available until next year, which is actually the same is true for Mitsubishi. And that really means that they are pushing right to the last minute. There might even be a gap when they are not allowed to manufacture any new equipment, right? Because they will have timed out on R410A at the end of this year. And if they don't get their new equipment line up and running on January 1st, they might not be making new equipment. So they're going to be really relying on that sell-through that Melissa talked about. And Mitsubishi said that they'll be doing trainings through their distributor. I really like that Daikin has the safety training, and I would like to see these other folks do it too. It would show me that the OEMs are taking the responsibility on for making sure that technicians have what they need to do the new installations. Okay, let's go to the next. So Melissa referred to this, okay, I'm sorry. Let me just take that sentence back. So there are, Melissa did refer to codes that have been updated to allow the installation of A2L refrigerants. And there are no training requirements right now for technicians. That is something that the EPA has put out a request for comment on about what training should be required for technicians, but there are no new requirements at this point. And just so you know, it would not be added to the 608 certification. That is, the 608 is only about ozone depleting chemicals, and if there's going to be any trainings related to the flammability of new refrigerants, that is going to have to be a new thing. It's going to happen somewhere else. But anyway, as part of ASHRAE, so ASHRAE 15 has standards for creating systems. So it's putting the pieces together. It's not this, ASHRAE 15 is not what the manufacturers have to adhere to, it's what you as contractors and technicians have to adhere to. So ASHRAE 15.2 is residential, and there's an addendum at the end there which has recommendations for technician work. And I'm highlighting it there in orange. These are recommendations, they're not requirements. But until there's a new requirement for training technicians, this is as good as we have. And I really strongly recommend that you adopt all of these as standard practice in your company. So if you are going to maintain, service, or replace equipment let's see, replace the refrigerant circuit or the refrigerant detection system. That's what RDS is. Then you have to keep records of that work, and it has to be accessible to future technicians, protected from the weather. You need to have, all these details that I'm showing here on the slide, including the quantity of refrigerant that was added or removed, and the results of any routine inspection or maintenance. So you just need to keep track of what you're doing, and you need to record it, and it needs to be validated and accessible to future technicians. So if you click forward once, Melissa, you will see that I have a red circle around validation. And so I just want you to think like, okay, what does it mean to validate, and how am I going to make this accessible to future technicians? And I will come back to that in just a moment. So if you then click to the next slide, which are more ASHRAE 15.2 recommendations. Regarding refrigerant leaks, the recommendations are adding refrigerant more than once every 3 years. So if you come back every year, if you come back every other year and add refrigerant, you need to consider that evidence of a refrigerant leak. Leaks need to be identified, repaired, and verified before you add refrigerant. After you do the repair, check all the joints, verify the refrigerant leak detection systems and the mitigation systems are functioning, replace the pressure relief valves that have been actuated. Now, I'm sort of using, my language is flopping back and forth between recommendations and like, you have to do this. And I just want to remind you, yes, these are not actual requirements, they're recommendations at the end of ASHRAE 15.2, but I am strongly encouraging you to adopt these as required practices with your technician. And if you click forward one more time, Melissa, you'll see I put another red circle around verified. And so the reason I did that is because I want you all to think about, well, how can I verify these things? Okay, so next slide. I think the best way to document repairs and to validate the correct operation of the system is to use communicating tools and store the reports in the cloud. And that's what these communicating tools enable you to do. Communicating tools use apps that are either on a phone or a tablet, and you can get with those apps instant diagnostics. That's very good for helping your technicians do good work. It also does record keeping, and you can store those records either by emailing them to your building owner. You can store it up in the cloud so that your own technicians always have access. Like, if you get a call in the middle of the day, an emergency call, and you have a technician, sort of change up their daily schedule and go out and serve this emergency call somewhere, they might not have had a chance to look at the records back at the office before they go to this job site in the afternoon. But if you're storing all of your records in the cloud, they can just pull out their phone when they're standing there next to the compressor, and they can, look at the records for all the last, several times that somebody went out and serviced that equipment. They can get access to that while they're standing there. So I'm a big fan of communicating tools and using all of the diagnostics that are available through the apps that work with the tools, and then storing your records in the cloud. And that's how you can validate. That's how you can keep records of all the work that you do and validate the correct operation of the system and validate leak repairs. Okay, next slide. A2L compatible tools. So there are some tools that you will not be able to use with the flammable refrigerants. And so you're going to need to upgrade your tools. Some of the tools I already mentioned, you do a recovery machine. The manufacturers of the tools are the people that will indicate whether the tools are compatible with A2L. So I can't even tell you like which class of tools will need to be switched up, but what I'm showing here. So what I'm showing here is some tools that Efficiency Vermont has for lending. And if you are interested in trying out some of these communicating tools, please contact me. My contact information is on the last slide. And so, this is the refrigerant manifold right in the front there, and then the little round thing is a digital micron gauge, and then I think that's the recovery machine in the back. So a big fan of the new tools, and you're probably going to have to change up some of your tools anyway. And when you do that, when you buy tools that are compatible with the new refrigerants, get the communicating tools. Okay, next slide. All right, I'm switching here to training your technicians. So the fundamentals of dealing with refrigerant systems are going to be the same with the new refrigerants and the old refrigerants, and really going forward, like all the fundamentals really are the same. And if you consider what it's going to be like working with propane in the future, and I just want to be clear, there is no propane in R32 or R454B. That is a totally different refrigerant, R290 propane. It's in our future, but it's not what we're working with right now in HVAC. But even when you're working with those highly flammable refrigerants, the fundamentals of how to make a clean and safe refrigerant system, they're all the same. And so with A1 refrigerants, I'm just reminding you, R410A is an A1 refrigerant. There were a bunch of best practices, and some of those were not actually required for working with A1 refrigerants. And I show there, as a little star, the things that are they were just recommended. However, some of those practices will actually be required when you're working with A2L refrigerants. And so, they were always a good idea. And if you weren't adhering to best practices before, what are you waiting for? They're the best practices. So establishing these practices in your company, everybody does this every time. It's really the best thing for your customers. It sharpens your technician skills. It's going to be required with the new refrigerants and going forward with the highly flammable refrigerants in the future. So, get on board. Yeah, I think I already referred to this. The whole question about repair versus replace, I think it's going to be a more urgent conversation when the cost of refrigerants goes up. And I just want to point out that there's a few other advantages besides avoiding the cost of the legacy refrigerants. And your customers can get access to the latest, greatest equipment and the improved efficiency from new equipment. So I hope that you can help your customers make a good decision about repair and replace, keeping all of those things in mind. Okay, next slide. I'm sorry maybe I haven't been saying next slide enough, but are we all, Alyssa, are you with me?
I think I may have missed the last one. Sorry about that one.
Okay, sorry.
For the repair versus replace, I didn't have it on the right slide for your last couple of comments. Okay. That's where it is now.
My apologies to the attendees. I'm in a little bit of a rush because I know that we're taking up your morning. All right, so the main thing I want to say on this slide is there's lots of great training information out there. And even though training is not required right now, there's really no reason that your technicians shouldn't be just on a journey of continuously improving their knowledge. Just because they got their 608 certificate 5 years ago, that's not the end of it. I think that companies should be sending out a 5-minute YouTube video every week and saying, here, find time to watch this. There's always ways to be improving their skills, and there's great free content out there. Now, not everything I show on this slide is free, but I have a bunch of links at the end that are places you can look for more trainings. And YouTube really is full of some good stuff. The people I like best on YouTube are HVAC School and AC Service Tech. Okay, next slide. Here is where we talk about transportation. So on the job site, you think about your tool compatibility. Starting maybe tomorrow, you might be installing A2L equipment, so you're probably going to need to upgrade your tools sooner rather than later. Locking refrigerant caps are a really good idea because these are flammable refrigerants. You need to have some kind of, I'm calling it a ventilation system or equipment here, but it's really, you need to have a fan, because if there's a refrigerant leak, you need a way to dilute it fast. So you need to have a fan on the job site. The fire extinguisher that you probably already have, it needs to either be dry powder or CO2 for the new refrigerants. It's a good idea when you're working outside and in the building too, is to like create a safety perimeter, and maybe you have some cones or some tape or something that you just like keep people away, because you're working with flammable refrigerants, and no smoking. In the warehouse, so there are these storage requirements, but in all likelihood, none of you are storing enough refrigerant in your own shop that you need to think about these, but it's on there in the slide deck in case you need to refer to it. Again, no smoking in the warehouse. And then transportation. So here's the maximum, 440 pounds. So that's a lot. You're probably not driving around with that on a regular basis, but there is a maximum for transportation. The new cylinders with the A2L equipment, they don't have a blowout valve. They have a pressure relief valve instead, because you don't want to just like lose the entire contents of a canister of flammable refrigerant into the back of your truck. So instead, they have a little pressure relief valve, but it means you need to store the cylinders with the valve on top so that gas is in contact with the relief valve rather than liquid. So it's okay to store them horizontally or like slightly, almost horizontally, but you need to rotate them so that the relief valve is on top. Have a fire extinguisher in the truck, and guess what? No smoking in the truck. Next. Okay, so new refrigerant. The cylinders are going to have a red band at the top, and we're going to stop having like different colored cylinders. They're all going to be gray, and the A2L refrigerants, the flammable, or slightly flammable refrigerants, going to have a red band around the top so that you know. I've heard a few different things about the reverse threading. Mostly I'm hearing people say that they will be reverse threaded, and that's so that you don't attach hoses to it and you're unaware that you're about to start deploying a flammable refrigerant. So now you need an adapter. For a while I was giving away adapters, like reverse thread adapters, but it's actually nice to have an adapter that's just on the hose itself, because then the adapter doesn't get lost. And as I said, there's a pressure relief valve instead of a rupture disc on the cylinder. And you have to, after you have a tank of virgin refrigerant or just like a new tank of refrigerant, after it's emptied, you actually have to return that you have to return the cylinder to a reclaimer to have the last few little molecules of refrigerant recovered there. That's part of the proposed refrigerant management rules. Okay, so the recovery cylinders, they do need to be A2L compatible, right? So it's not the rupture disc any longer, it's the pressure relief valve. You can't put A2L refrigerants in the old recovery cylinders. And you need to adhere to best practices when you do recovery so that you're avoiding an explosive mix of refrigerant and air. So I already said this before, but evacuate the cylinder, purge the hoses, make sure that your recovery machine is A2L compatible, and purge the machine when you are done recovering. And I already said that about transportation, so I'm just going to skip that. Next. Ooh, safety systems. Is that the slide that you're on, Melissa? I hope you don't have to say anything if that's the slide. So,
yes.
And Leland, you've got
you're not
just a time check.
Yeah.
You've got about 3 minutes, so I'm not sure how much more content you have. I'm sure we can stay a little longer for questions too.
I have this in one more slide.
Perfect.
And I can stay for more questions. This is why I was rushing so much.
Should have gone faster.
I hope I haven't been rushing too much.
Yeah.
But anyway, so safety systems. This is something that the OEMs have to build, not you, but I just want you to know what's involved in the safety systems. It's a sequence, and there are, this is the basics of a safety system. If the refrigerant detection system, the RDS, senses that there's refrigerant that's been leaked, the compressor will shut down. So it will stop pressurizing the system and recirculating refrigerant. The next thing that happens is that the fan, so think now like central AC, the fan will go into circulation mode. So if it was off, it will turn on. What that means is that the refrigerant that's detected is now going to be diluted into the occupied space. That's the normal part of this response to detecting refrigerant. And I just want you to understand that. That's normal, and that's part of these safety systems. And then the last thing is, this is not going to be present in all systems, but the last piece to get
sort of added in to the safety systems is that the space may become ventilated. So there might be a requirement to install a ventilation system like in a small utility room where like you wouldn't want the utility room to basically be filled up with refrigerant and then create an explosive mix. So that room might need to be ventilated. And that's very specific to exactly what the application is. Okay, last slide, next slide. So Melissa already referred to this, but I just want to like really drive this home. These are not, the rules for this haven't been released yet, and we're expecting the rules in October. But we've already had a look at them, and they've been out there for comment for some time, almost 6 months. So the proposed refrigerant management, which is, you know, we're expecting something pretty close to this, is under leak repair. Systems that have more than 15 pounds of refrigerant and have a global warming potential of higher than 53, so that's definitely R32 and R454B, they must be repaired. But the exception is residential and small commercial. Does that mean you shouldn't repair leaks? No. Repair leaks, for sure, repair leaks. But the new regulations are only requiring it in systems that are higher than 15 pounds and have a global warming potential that's higher than 53. You do need to verify that the leaks have been repaired. I already talked to you about verification using smart tools. And if you have a system that has higher than 1,500 pounds of refrigerant, you need to have an automatic leak detection system. You know, this is not your household stuff here, but I just want you to know it's in the proposal. For reclaimed refrigerants, effective starting 2028. And so back in the reclaimed refrigerant section of things, I said this all comes into effect in 2028. This is why. So the initial charge in some sectors, not all, will need to have at least some reclaimed refrigerant. And for recharge, you're going to have reclaimed refrigerant, not virgin. So starting in 2028, everybody's going to be using reclaimed refrigerant, and that's why I said we all need to do a better job reclaiming refrigerant. And then training, you know, that we haven't really seen what the proposal is there, and as I already said, it's going to be part of the AIM Act, not Section 608. Okay, the next slide is some training sources. When you get the slide deck here, Bren, we're going to send the slide deck to all of the participants, right? These will be live links, and you'll be able to click through on these. And one more slide which shows Melissa's email and my email. Remember, if you wanted to talk to me about borrowing some of the new communicating tools, you can contact me directly. You can contact either of us if you have questions about what we presented today. And that's the end.
Thanks for hanging with us, everybody. Good questions in the chat.
Yeah, thanks so much. For anybody that has additional questions or things that haven't been covered, now's a good time to ask those. We can raise your hand. It's always nice to hear your voice. Or if it's easier to put it in the chat, that works for us too. There is a short survey once you go to sign off. It's only about 5 questions. We really value your feedback. It helps us improve our trainings and plan for additional training content in the near future. So please let us know how we did today and what else you'd like to see in the near future. And thanks so much for taking time out of your busy week to join us. We really appreciate you making time for it, and it's always great to have you join us. Thanks for all your excellent questions, really very helpful. And we'll get the recording for this on our online trainings. We'll aim to get that within the next week. Hopefully our web team will cooperate. And as Leland mentioned, once we log off, I can get the slide deck and email that out to everyone as well. So you can look through that there.
Yeah. So Leland, you couldn't see the chat. Most of the specific questions that were asked, which there's some great questions, were addressed in your presentation later or in the chat already. But one thing, a couple people talked about just sort of other sectors, refrigeration and multifamily and stuff. So if you have specific things you would like to know or need some guidance getting pointed toward, please do not hesitate to email us. we would
Okay,
be glad to
Yeah.
help point you guys at whatever you're interested in. Maybe we can have another
Yeah.
session sometime about other sectors. I don't know, but for now, shoot us an email if there's something that you're stuck on.
yeah, Alex, I see you're referring now to refrigeration, and please reach out to us. We do have other folks in the company, Melissa being one of them, that works more on the refrigeration side of things.